picking up where we left off with our cyclic quadrilaterals. So we did everything with this one. Okay, so now we want to find the measure of this arc. So if we look at this inscribed angle here, that is defining this arc that we're looking for. So if this is 62, double that is going to be 124. So that's the measure of that arc. And then let's see, the other arc, if these two arcs together make up 360 degrees, then this arc is going to be 360 minus 124 is going to be, let's see, 236. So if this arc is 236 degrees, then this inscribed angle that defines that arc is going to be half of that, which is 118 degrees. And then same thing with the last one. This arc here is going to be double this inscribed angle, 260. And then the other arc will be 100, and then that makes this angle 50 degrees. Alright, so to kind of pull this all together, there's the second question here. Here is another quadrilateral with a circumscribed circle. What is the value of alpha plus beta? So we have alpha here is the measure of this angle, and beta here is the measure of this angle. So the question is, what is the measure of alpha plus beta? So let's think about this. If you look up here, this inscribed angle defined an arc that was here, and then this inscribed angle defined this arc. Those two arcs together made up the whole circle. So same thing is happening here. If I look at, if this is alpha, that angle is defining this arc. So whatever this arc measure is, this angle will be half of that. And then with this other inscribed angle beta, whatever this angle measure is, this arc is going to be double that. So let's think about the fact that these two arcs in the circle make up the whole circle together. This arc plus this arc is the whole circle. So, in other words, this arc plus this arc, the measure of this arc plus the measure of this arc is 360 degrees. Let's start writing this down. So we're going to call this arc DCF. We'll say arc DCF. Like that, with a little arc above to show it's an arc. Arc DCF and arc DEF together make up the whole circle. Okay. Now that we have that established so far, now the measure of arc DCF plus the measure of arc DEF will equal 360 degrees because they make up the whole circle. So if these inscribed angles define each of these arcs, the inscribed angles are going to be half the measures of the arcs. So let's see. So the measure, or we'll just say angle B, beta, alpha and beta, are going to be the same as the measure of arc DCF divided by 2 plus the measure of arc DEF divided by 2. Which also means that we can just take the measure of arc DCF and the measure of arc DEF, the measure of this arc and the measure of this arc, and divide it by 2 to get alpha plus beta. So the measure of arc DCF plus the measure of arc DEF divided by 2, which is 360 divided by 2, which is 180. So alpha plus beta has to be 180 degrees. So, and this is going to be true because we were so general about this. That's going to be true for any cyclic quadrilateral. So for any cyclic quadrilateral, I'm going to write this in a different color so you can kind of see the difference. So in a cyclic quadrilateral, opposite angles add to 180 degrees. So this is a way that you can determine if a quadrilateral is cyclic. This is a way you can find missing angles if you know a quadrilateral is cyclic. So this is very useful information. All right, let's look at last thing, 4.3. I'm going to kind of go through this quickly because I did not go through this in all of my classes. And I don't think it's as important as the rest of this lesson. It's just kind of applying what we already learned from this lesson and kind of just exploring it a little bit more. So it says draw a diagonal BD. So that just means connect B and D with a chord. So I'm just going to use my straight edge here. Okay. How will this diagonal relate to the circumscribed circle? So let's think about this. This diagonal, if I have a circumscribed circle, which means it's going to go through all these points, that means that I'm going to have some, this is a really bad circle, you guys, but it's fine. I'm going to have some inscribed angle here because this point is on the circle. So this inscribed angle is going to be 90 degrees, right? And then, so this inscribed angle is defining a 180 degree arc. So let's see if I can maybe show this with colors here. So this angle is going to define this arc here. So this is 180 degrees, which means that this is a diameter of the circle, right? If this line is splitting the circle in half, this is a diameter. Okay. And then it says construct the center of the circumscribed circle for quadrilateral ABCD. Label this point O and explain why your method worked. Okay, so the center of the circumscribed circle is going to be, well, it's going to be wherever, we talked about how this is the diameter. So it's going to be right in the middle of the diameter here. So I suppose we could just kind of find the middle of this. Obviously there is a way to find the midpoint with a compass and stuff, but if you have a ruler or something, let's actually use a ruler. I'll use my protractor as a ruler here. Okay, that's about 5 centimeters. So I'm just gonna kind of mark in the middle there. Okay. So that's gonna be the center of our circle. And then we can construct the circumscribed circle. We know that all of the points should be on the circle, all of the vertices should be on the circle. So hopefully we'll still be able to see my actual circle, even though I scribbled a bad circle over it. Make this a little taller so you can kind of see what I'm doing. Alright, so my estimate, my sort of sketch circle wasn't too bad. So there's our circumscribed circle. Could we follow this procedure to construct a circumscribed circle for any cyclic quadrilaterals? So if you think about our process there, the answer to that is no, because the only reason we were able to follow that process was because we had a right angle here. So the right angle told us that this line segment BD would be our diameter. Find the midpoint of that. That's going to be our center of our circumscribed circle. So it would only work if we have a right angle in our quadrilateral. All right, I think that's about it. Let me know if you have any questions.